Okay, so we have two positive charges A and B placed along the same line as shown by the dotted line, and both are positive. Now the task is to place another charge T at some position. It can either be in between A and B or outside A and B in the same line, and it can be either positive or negative. Now we need to find out for which of these conditions can all three charges balance out their attraction and repulsion forces and the entire system can be in equilibrium. Let us take case 1 where we have uh, T. Let's take T as a positive charge. The dark red one is positive. If I place a positive charge in between A and B, let's see what would happen to the forces on each of them. A being positive will be given a push by T. It will be repelled by P. So it will get this pushed away in this direction by T and will also get pushed away by B. What will happen to T? It will get pushed in this direction by A and in this direction by B. And B will be pushed in this direction by both A and T. So we can see here that only in this case, in the case of T, the forces are balancing out. A and B, the forces cannot cancel out. So let me put that as a red mark, that this cannot cancel out, this cannot cancel out. Only the middle force can cancel out each other for the middle charge T. Now let's look at what would happen to the second case. In the second case, if I place T as a positive, anyway A and B are positive. If I place T as a positive charge outside of these two but in the same line, then T will be repelled by both A and B, pushed away in this direction by A and B. What will happen to A? A will be pushed away by T in this direction and pushed in this direction by B, and B will be pushed away in this direction by both A and T. So we see again here that there is no cancellation possible of the forces in these two cases. Both are in same direction, no way the forces can cancel out. So you cannot attain the equilibrium position of the system here too. Let's take the third case where I am taking T to be a negative charge. A negative charge, let's place it in the middle. So what happens in this case? These two are positive as always. A will be attracted by T towards it in this direction and pushed away by B in this direction because A and B are both positive, and T will be attracted by A towards A, and T will also be attracted towards B in this direction. And what happens to B? B will be attracted by T towards it and repelled away from A by it. So in this case, you see all the forces are opposite to each other. A has two opposing forces, T has two opposing forces, B. So we can place the target T appropriately in the middle somewhere based on the magnitude of charges A and B and attain equilibrium in this position. Let's take the fourth case where I place T as a negative charge outside but in the same line. A and B are positive. So T is attracted towards A and attracted towards B. A is attracted towards T but pushed away by B, pushed away from B. What happens to B? B is pulled towards T, attraction, pushed away from A in this direction. So we see here again that this is not balancing out, this is not cancelling out. So the only possibility of cancellation is with this. So let's use different color and see which all can become green. So these cancel out, okay, these cancel out, and whereas in the third case you can see all of them are opposing each other and can cancel out. So we have three greens only in this case. So this is the case where if we have two positive charges, point charges, and we place a point charge in between them at some position appropriately according to the magnitude of the charges, then we can attain an equilibrium position. Thank you.